A battery breakthrough by a U.S. scientist right here at the Georgia Institute of Technology. Zhonglin Wang and his research team have invented a battery that can be charged simply by walking, physical movement. The battery converts the physical energy of walking into chemical energy and then stores it. Now, this power cell can then convert that to electrical energy on demand. The battery can harness enough energy to power a small calculator right now. The battery has been named one of Physics World's magazine's top 10 inventions of 2012. And joining me is the inventor himself, Zhonglin Wang, a professor at Georgia Tech. Glad to have you with us. Sorry the football team didn't do any better, sir. But the battery's doing great. Show us what this is and explain a little bit about it.
So this is something going to change our future living of life. This, what I have is that what we call nano-generate. This convert tiny physical motion into electricity. And what I have is about 10 LED lights. Once I blow this with my breath, you can see the LED light blows. Okay?
And that would be equivalent to charging a battery. It
Yes,
can be used to do that.
Miniaturization version one.
But show me.
Inside this, okay.
I don't know if I believe you. Get a close-up of this. Now, our lights may be too bright on this to show it, but I saw it working in the dark. Oh, there we go. See that green light coming on? All right, now, so if I put this on my car, driving down the road, and had wind blowing through it, I'm going to be generating electricity?
Exactly. This is, you can put it anywhere you want.
Bicycle.
As long as tiny physical motion. You can put on your skin, on the road, in your shoes, on your window, whatever is tiny physical motion, like my breathing, can lit up this 10 LED. That means we have about 50 volts generated. When we miniaturize this one into a small device and inside anywhere battery, so we have one device.
So that device, as we see there, is just like about the size of a nickel or not even as big as a euro.
Right. So then miniaturize this one. Inside here, you have a full self-charging power pack. We don't call it battery because it has an energy converter and a battery function. So therefore, once you use this one, you're walking, this is charging and ready to use.
So it's more than a battery.
More than a battery.
You're charging this one up. I see there's a plus on this side.
Yeah.
And I assume the other side would be a minus.
Yeah.
And so I'm using that, and if I move it like this, I'm charging it?
When you put it under the shoes, in your shoes, when you're walking, you
I think we have a
this.
picture of that.
Yeah.
A picture of how it would work if you would have it on the sole of your shoe, the way that it would work in order to create electricity. Now, if I were, does it work with centrifugal force? In other words, if I were to put it on a wheel, the wheel of a car, and go around and around, would it do it?
Yes. This is because wheel can drive this one. Much bigger ones, cycle by cycle, that's you harvest the energy and store it and ready use for other purposes.
Big question. I mean, how long till this technology, when do I see it in my life? What can I use it for?
I have been working on this technology for 8 years, and now it's well established for applications. I think it's next 3-5 years we're going to find some true applications in our real life.
Now, as it stands now, I mean, you're charging a battery, and that can be used to charge anything, mostly small electronics right now.
Even we look for small electronics, for example, like cell phones, IP3 player, but we look for big too. If we put this one in the future in the ocean wave, we can harvest the ocean wave energy for our large scope energy need. So we think we look at the small, but we have to look forward for the big.
So this can be, you can take it to a much larger size.
We can scale up, yes, much scale, large scales. And this, according to our calculation, this is 1 cubic meter. 1 cubic meter gives you 30,000 watts of energy.
30,000 watts, that's a lot.
Yeah, so this we look at this small, but nanotechnology can one day change the life we live. We look at small, but can solve more big problems.
Congratulations to you and your team. I can't wait to see the finished product as we come out. This is something that could really change the way that all of us charge our batteries and could solve a lot of problems. We'll wait and see. I don't think we know what all of the potential is here. We're going to find out thanks to Dr. Wang and his team.